Okay, hello, good morning, everyone. Happy Saturday morning. Welcome back to our November week one. All right, so happy holiday to y'all. So what are we doing today? We are doing revision. Okay, so today will be another revision week. Okay, we are going into chapter 8 revision, which is the atom chapter. Atom, molecule, and ion. Okay, should be pretty familiar to y'all. We just learned this like what, 3 months back. Okay, we learned this during this MCO also. So should be pretty familiar to you. So I hope you have your November notes ready. Okay, you should already receive it by now lah. So if you don't, then you can just copy down the answer first, or you can screenshot the answer first. Okay, you can put it into your notes later. All right, so let's begin. Question one. The diagram below shows 3 types of substance. Okay, this should be pretty familiar to you. So if you don't, then we shall, revise along the way. So state the ionic substance. Ionic substance should be P. Okay, so if you forgot already, it's okay. Gas Q should be your helium gas. Helium gas is made from atom. Okay, purely made from atom. So if something is made from atom, they are mostly metals. They are mostly metals, unless they state that it's a group 18 gas. Remember what is group 18? Kumpulan 18, all the very stable gases, your helium, argon, krypton, xenon. So those are the very stable gases. They are the only gas that exists in atom. Okay, the only gas. All other gases, they are all molecules. So when we talk about water, water is a molecule. Okay, water is a non-metal. Atom is a metal. Okay, and salt is a metal plus non-metal. So when you have metal plus non-metal, this is a molecule. This is an ionic substance. Okay, I hope you still remember. Okay, so B, draw the arrangement for particle Q. Okay, so how is an ionic substance arranged? So there will be negative, positive, negative, positive, positive, negative, positive, negative. So it's like a how do I say this? It's like a electrostatic thing. Remember electrostatic, positive, negative, they attract. Okay, positive, negative attract. So you draw it like this. You can fill up this space lah. I'm just drawing it very small here. So C, state the type of particle Q and R. Yeah, I think I'll give you the answer already. Okay, Q is atom. R is your molecule. Okay, so D, state one characteristic for gas Q. So we know that gas Q is an inert gas. Okay, inert gas. In BM, we call it gas nadir. What does it mean by nadir or inert? That means this is stable lah. Okay, the meaning of nadir is stable. Inert means stable. That means they won't react with anything. You burn it, nothing will happen. You add oxygen, nothing will happen. You add acid, you add alkali, you do whatever you want, nothing is going to happen because they are very stable. Okay, so one characteristic of gas Q, they are very stable. Okay, sangat stabil. They are gas at room temperature. They will not combust. They will not react with any substance. Okay, tidak bertindak balas dengan sebarang bahan. Sure. Okay, there are many answers here. So give one example of particle as Q. So you can say helium, okay, neon, argon. Okay, take your pick. Any group 18. Okay, kumpulan 18. Remember what is kumpulan 18? Remember your periodic table. You learned this in Form 1 already, and you're learning it again once in Form 4. So no excuse for you not to know. All right, very simple question. Moving on, let's go to question 2. Again, we have the same question. So this is salt. Salt is ionic. Ion. Sugar is a molecule. Okay, why? Why is sugar a molecule? Sugar is a carbohydrate. Okay, carbohydrate. What is carbohydrate? Carbo means carbon. Okay, hydrate means water. Hydrate what? You hydrate yourself means you drink water. So is water made from? Water is made from hydrogen and oxygen. So is carbon a metal? No. Carbon is a pencil tip. It's not a metal. Is hydrogen a metal? No. Is oxygen a metal? No. Three, they are non-metal. So since everything is non-metal, right? Definitely this is a molecule. Okay, simple as that. So your protein is also a molecule. Your fat is also a molecule. Now they're all molecules because they all consist of non-metal. All right, easy, eh? So B, give two other examples of substances that are formed from the same type of particle as salt and sugar. Okay, very good question. So what is made from salt? Salt is an ion, right? Anything that is same as salt, that's a rust. Okay, karat. Okay, karat. The scientific name for rust is iron oxide. So can you see? Iron is the metal, oxygen is the non-metal. Iron oxide, besi oxida. That's the scientific name lah. If you say, sir, I'm too lazy, can I just write rust? Yeah, sure, karat. And of course, sugar. This is same as your oxygen or oxygen gas. So many things here. Hydrogen gas, water, ammonia, whatever you want to write here. So next, give two examples of substance that contains oxygen that exists in the form of molecule and ion. Okay, molecule and ion. So what is ion? So what is molecule in oxygen form? Okay, in terms of molecule, you have your oxygen gas. Okay, oxygen gas. And in terms of ion, you have your rust law. Okay, iron oxide. So oxygen can exist in two forms, which is the molecule form, the oxygen in the air, and you have rust, which is the rust. Okay, iron oxide. So as you can see, the questions they are more or less the same. They are more or less the same, they won't go far from this. So anyway, let's look at question 3. Fill in the blanks, the correct answer. So in the periodic table, the elements are arranged horizontally in order of increasing proton number. Okay, proton number. That means your periodic table, they will follow proton number like 1, 2, 3, 4, 5, 6, 7, 8, and go up. Like I said, proton number is the most important number. We don't really care about neutron number, and we don't really care about nucleon number. Nucleon number is the total, remember? Why do we care so much about proton number? Think of it this way, proton number is like the ID number of an atom. I've said this millions of times, and I'll say it again. Proton number is the IC number. Your IC number, only you have it. Proton number, only they have it. For example, oxygen. Oxygen is proton number 8. Okay, oxygen has 8 protons. So number 8 is always oxygen. It's like his IC. 8 is always oxygen. There's no one else. 100 years ago, 1,000 years ago, billion of years ago, they are 8 proton is oxygen. 1 billion year later, oxygen is still number 8. So this is the ID number. Okay, so this is why proton number is the only thing you care about. So number 2, elements in the same group have the same chemical properties because they have the same, the same number of valence electron. Okay, so what is valence electron? Let me repeat this again. That's the electron at the outermost shell. Okay, if you still remember, sulfur is 16 proton. Okay, 16 proton means 16 electron, because proton and electron is the same. And we, in chemistry, in this chapter, we don't write 16. We write 2.8.6. Why? Because this is how they are arranged. Okay, because 16 doesn't give you any info. But when you arrange like 2.8.6, because the total 2 plus 8 plus 6 is 16, right? Now remember, first shell you can put 2, second shell you can put 8, third shell you can put 8, fourth shell you can put 8. So you just starting from the first shell, you fill the first shell, and then you fill the second shell, you fill the third shell. So if you do it this way, it's 2.8.6. So what is the valence electron? This is the valence electron, the outermost shell. Why do we care about the valence? Because valence determines where they are. Okay, like in this case, this is group 16. Okay, group 16. So why not 6, sir? Because again, like I said, from group 3 to group 12, we don't care. I'll talk about this later. Okay, so valence electron. So the table below shows the symbol that represent 4 element W, X, Y, Z. Determine the proton number. So where is the proton number? This one. Proton number is always the smaller number. Okay, it's always the smaller number because in your nucleus, the middle nucleus is proton plus neutron. Okay, so if you take away the neutron, that's the proton. That's why it's always the smaller number. This 23 here is the nuclear number, which is the total number. The total number is always the bigger number. The proton number is always the smaller number. I mean, common sense, right? Okay, of course, nucleon is the total. So draw the electron arrangement. Let me write out first. This is 2.8.1 because 2 plus 8 plus 1 is 11. This is 2.8.2, 2.8.3, 2.8.8.2. I see. Third shell can only put 8. So after you fill in one shell, you go to the next shell. So how do you draw this? Okay, 2, 8, 1. And please remember, draw your electrons in pair. Can you see? Pair. Please don't be cute and draw your electron like this. Okay, you're not drawing a clock, please. Draw it in pairs. They are always in pair. Don't ask me why, because that's the way it is. Okay, the next one, 2, 8, 2. Okay, why is it like this? You might say, hey, sir, why? I thought you say pair one. Okay, here's the thing. Your electron, okay, let me talk about the shell, has 4 rooms. Okay, it has 4 rooms. Each room can put 2 electrons. But here's the thing. Electron, they are negative. If you are a negative electron, you wouldn't want to share a room with another negative electron because negative and negative, you don't go well together. So what do? You fill up the first room first, and the second guy will fill up the second room. Okay, and there's a third. If there's a third guy, they will fill up the third room. If there's a fourth guy, they will fill up the fourth room. So they will go to separate room first because they don't really like each other. Electron and electron, they don't go very well. Okay, because same charges repel. Charge sama menolak, charge berlainan menarik. You learn this in electricity already. So what about the fifth guy? When the fifth guy came in, 4 rooms are filled up. No choice, law. They have to share one room with one electron. If the 6th guy come in, share law. 7 guy come in, share law. 8 guy come in, share. Now, if the 9th guy come in, then how? Oh, no choice law. Then he has to go to the another shell already. So you hope what I'm trying to say here. So they will fill up 2 rooms first. Okay, 1 room, second room. So 2.8.3. Okay, 2, 8, 3, 1, 2, 3. They will fill up the 3 room first. Only they will fill up the 4th room. And then if the 4th room is taken, then they will repeat again. So 2.8.8.2, it's 2, 8, 8, 2. Okay, so by looking at this, you know this is group 1, group 2, group 13, group 2. And the period the shell shows the period. This one got 3 shell, so this is period 3, period 3, period 3, period 4. So hope we didn't forget this. Anyway, so C, the table below shows the proton number 10 from P to Y. Write the electron arrangement. Okay, they already give you the proton number here. So how do you arrange? This is just 2 lah. This is 2.8.3, 2.5, 2.8.8.1, 2.8.6, 2.4, 2.8.2, 2.8. Okay, I want you to pay attention to this and this. When the first shell is full, this is what we call duplet. Okay, when the outer shell, second, third, fourth shell, they are full, we call it octet. That is full. Octet is full. So by this definition, you should know this element and this element, they are inert gas. They are very stable. If you have 2 on the outermost shell, will you get another electron? No, you won't. Will you throw another electron? No, you won't. You are very happy already. You have all the electrons you need, so you are very stable. You see, all chemical reactions are about exchanging electron. If I'm a metal, I will throw electron. Okay, like this case here. You see, when you are 2.8.3, you are not really happy with this. Okay, you will throw this 3 away. And if you're like this, 2.5, you're not happy as well. You will get another 3 to become full. As an atom, your objective of life is to make yourself full, to fill yourself up. Okay, to make yourself octet or duplet. In this case, you see, this guy is even crazier. You see, 2.8.8.1. Oh my God, I have 1 extra at the outermost. I really want to throw this thing away. So you will try your best to throw this thing away. That's why this element is very reactive. Okay, very reactive. Whereas this guy, you see, 2.8. I'm so happy already lah. Do I need to take another one? No. Do I need to throw another one? No. So this is very stable. W is like very happy now. Okay, I'm making sense, Okay, so next, number 4, periodic table. So what is number 1? Okay, this going horizontal is your group. Okay, kumpulan. You might say, sir, I thought kumpulan is going down. Yes, this is going down. You see, just because I'm going left to right doesn't mean I'm going to left to right. If I'm going left to right, I'm talking about columns. Okay, if this makes no sense to you, think of it as your x-axis. Okay, when you draw your x-axis and y, x and y, you see x is horizontal, right? But you're talking about vertical lines here. Okay, this is coordinate 1, coordinate 2, coordinate 3, coordinate 4. So think of your group as x-axis. And then your y will be this period color. This is y-axis. So y-axis is horizontal, vertical, but you're talking about horizontal rows. So same thing here, horizontal rows. So it's just actually x and y, but chemists, they don't like to call it x and y because it's so not fancy. So they give you a name, x is kumpulan group, and then y is period color. It's the same thing. Okay. So how are the elements arranged? Okay, I said this already just now, is by increasing proton number. Okay, nombor proton bertambah. Okay, bertambah meningkat lah. So they will arrange 1, 2, 3, 4, 3. Wait, why is this periodic table so weird? Okay, there should be this one should be not here. There should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They will arrange according to proton number. So you see how important proton number is now. We don't really care neutron and nucleon because it doesn't tell us anything. Proton will tell us where they are now, which group they are, which period they are, and we will know whether this is a metal, whether this is a non-metal, whether this is reactive or non-reactive. It tells us everything. Okay, so see, the following shows a statement: silicon is a semi-metal element. Okay, so where is semi-metal? Semi-metal is here. You learn this in Form 1, right? This is your metal. Metal is on the left-hand side. Non-metal is on the right-hand side. The middle one is usually your semi-metal, which is this Q here. So circle P, Q, or R. Okay, so that will be your Q. Why is silicon classified as semi-metal? Okay, why is it called semi-metal? Because they have characteristic of metal and non-metal. Okay, because they have characteristics of metal and non-metal. Mempunyai ciri-ciri logam dan bukan logam. Okay, so this silicon is a very special element. All your electronic stuff, do you know that, is made from semi-metal, which is silicon. That's why if you are in the silicon industry, that's why silicon, we call it semiconductor. Okay, semiconductor. You know what's a semiconductor? Okay, this is not coming out in your exam, but this is a fun fact. Do you know what's a semiconductor? All your electronics are made from semiconductor. Your camera, your phone, your screen, your computer, your graphic cards, your processor, even your circuit board is everywhere, right? Your washing machine has a circuit board. Your calculator has a circuit board. Your fridge has a circuit board, your oven has a circuit board, your car has a circuit board. So everything is made from silicon. As long as something to do with computer, that means this is made from silicon. Okay, so this is why, okay, have you read the news lately? Because of this COVID, currently the whole world is undergoing something what we call a silicon shortage, a semiconductor shortage. This is why nowadays, many things related to computer, they are so overpriced. Any gamers here? Any gamers here? If you're talking about graphic cards, you know what I mean lah. Okay, there's a shortage of graphic card everywhere, and graphic card is double in price. Do you realize something like this? Okay, 1,000 something graphic card nowadays is 3,000 something because all the crypto miners, they are buying everything, and now there's a shortage of silicon. Okay, you don't believe me? You go and buy a new car now, you understand what I mean. You go to Toyota, you say you want a new car, they say, okay, sure, you pay for it. 3 months later or 6 months later, you get your car. Why 6 months? Because now they can assemble a car for you, but there's no circuit board to make the computer function. If there's no computer, your car cannot run. Okay, so they can assemble everything, but the computer is not there. So they have to wait for it because the whole world is short in supply now. There's not enough silicon. Okay, so you get what I mean. So if you are very familiar with computer, you get what I mean. There's a shortage of everything now. Oops, sorry, there's a disconnection here. Hang on. Okay, my screen is disconnected already. Give me a moment. Okay, not the first time already. That's happened multiple times in this week. I have no idea why. Okay, give me a moment. I was just cursing about the computers, cursing about the silicon shortage. Now is this is some kind of karma. Okay, hang on. Okay, here we go. All right, so silicon shortage. Next one, let's look at number 3. Name other semi-metal element. Okay, this one they won't ask. Okay, this one they won't ask. Okay, but if you are really interested, there's another one called gallium, I think. Okay, gallium. To make all the circuit boards, you will need all these things. But the main thing is silicon. The main thing is silicon. So where is silicon from? Silicon is from sand. Okay, silicon is from sand. You might say, sir, how can we get sand shortage? So are you saying that our graphic card is made from sand? Our processor is made from sand? Yeah. Your Intel processor, your AMD processor, your NVIDIA graphic card, your AMD graphic card, they are all made from sand. But it's not as easy as you think. Okay, it's not easy as you think. Okay, if you're very familiar with graphic card, you will know what I mean. The graphic card nowadays is as small as 7 nanometer. Okay, the Ryzen CPU is a 7 nanometer platform. So they have to make the sand 7 nanometer small to become your processor. So if you have no idea what I'm saying, then okay, let us move on. Okay, before you confuse yourself. Okay, anyway, so let's look at number 5. So this is your periodic table. So V, W, X, Y, Z here. So which element has 7 protons? Okay, that's very easy. 7 protons, that means 2.5. 2.5, right? Because 2 plus 5 is 7, right? So they fill in the first shell 2, second shell 5. So how do we see this? Let me repeat this again. Group 3 to group 12, that's not our business. Group 3 to group 12, please ignore. That's not our business. So we will go from group 1, group 2, group 13, 14, 15, 16, 17, 18. The rest we don't care. Okay, so 5 is group 15. First 1, 2, 13, 14, 15, 1. So group 15, this one got 2 layers, right? 2 layers, that means period 2. Okay, period 2. So who's in group 15, period 2? Group 15, period 2. So that's your Y. So can you see the usefulness of proton number now? Why is proton number so important now? Because when you know the proton number, you will know where the element is at. In this case, it's here. Okay, so neutron number, do you know why we don't care about neutron number now? Neutron number, it doesn't say anything. If I give you the neutron number, oh, this is neutron number 4. Okay, so what? Where is it at? Don't know. What's the chemical properties? So you see, when I know this is group 15, I know this is a non-metal. I know this is a non-metal. I know this element needs another 3 electron to be stable. So this Y, it will turn into Y3 minus, because this Y will take 3 electrons to make this full one. You see, proton number tells us everything. That's why proton number is very important. It's the ID number, like I said, the IC number of the proton, of the element. Okay, so next, draw the electron arrangement for the atoms stated in A1. So Y is 2.5, right? So 2, 5. 1, 2, 3, 4, 5. Now, like I said, you fill in all the 4 rooms first, and then you start from the first room again. So 2.5. Okay, 2.5. So which element has 2 valence electron? Very easy. 2 valence electron means this is group 2. Okay, group 2. So which one is in group 2? This guy lah. There's only one group 2 here. So W. Okay, group 2. C, which element forms a negative ion? Okay, very good question. Negative ion, that means they have 5 electron, 6 electron, or 7 electron on the outside, right? Because if I have 5 electron, I will take 3. If I have 6 electron, I will take 2. If I have 7 electron, I will take 1. On the other hand, if I'm 1, 2, and 3, if I have 1 electron on the outside, I will throw away this one. If I have 2, I'll throw 2 away. If I have 3, I'll throw 3 away. So you might say, sir, why throw 3? Why I cannot take 5? Which one is easier? You tell me. Would you want to throw 3 away, or would you want to take 5? Of course, to throw 3 is easier. Okay, and in this case, throwing 1 is much better than taking 7. Why would you take 7 electron? That would make no sense. You can just throw this away and you're happy. So they will choose the easiest route. So 5, 6, and 7. That means anything from group 15, group 16, group 17, they will become negative ion. Easy as that. So who is 15, 16, 17? There, you got 2 here. So in this case, Y will become Y3 negative, Z will become Z negative. Because Z needs to take 1 to become stable. So you have 2 answers here. You can either say Y or you can say Z. That's up to you. They form negative ion. So next, U and V are 2 elements in the same group. What inference can you make about the chemical properties? Now, what is inference again? Inference means why. Why? So chemical properties, since they are in the same group means same chemical properties. Okay, same chemical properties. Ciri, kimia, yang sama. Okay, so why? Why do they have the same chemical properties? Because they have the same valence electron. Okay, electron valence yang sama. Okay, electron valence yang sama. So the valence electron will tell you everything about, since they are in the same group, they have the same valence electron, they have the same chemical properties. Okay, this is the beauty about periodic table. As long as they are in the same group, they have the same properties. That means you know these 2 guys, but you don't know these 2 guys. But even you don't know them, more or less they are the same. Okay, if these 2 they are very, very reactive, that means this guy is also very reactive. It's the same. Okay, same thing here. If you know group 18, you know that these 2 guys, they are very stable, but you don't know these 2 guys. Same thing, they are very stable. Okay, yeah, sure, there may be some small differences, but more or less the same. That's why they are called a group. When you belong to a same group of people, you are the same. Okay, if this group is a studying group, so if you are inside means you like studying. Okay, if you don't like studying, you won't be in that group. So you get what I'm trying to say. So this is why your periodic table is arranged in such a way. If I say, sir, why is the periodic table so weird? Why is there a gap here? Why can't they just fill in block by block this? So this is purposefully done. The chemists, they use many, many years to say, this is the best way to arrange so that all the elements in the same group, they behave the same way. This makes your life so much easier. Right? So periodic table is a very, very awesome thing. It takes like hundreds of years for them to come up with this thing. So anyway, number 6, figure 2 shows the position of element P, Q, R, S, T, U, W in the modern periodic table of elements. Okay, they are not the actual chemical symbol, fine, whatever. You see, group 3 to group 12, like I said, this is none of your business. We don't care. Okay, you just need to know their name. We shall talk about that later. So name element P. Okay, element P is the first one. They want the name of it. This is hydrogen. Okay, before you freak out, sir, why would I need to know the name of this? Chill, they won't ask. Okay, they won't say, oh, what is this? Please name me this thing. Okay, for a fact, I know this is chlorine. That's because I've studied chemistry for like 15 years. I know this is chlorine. But even if you ask me what is you, I can't tell what the hell is you. I also don't know. So you don't need to know. You don't need to know. They won't ask questions like this, so don't worry. Okay, next one, B, state the element with proton number 5. So 5 is 2.3. That means this is group 13. This is period 2. So who is group 13 period 2? Group 13 period 2. So there's only one here. No, there's R. So very obvious one. If you get something like here, that means something is wrong. Okay, that means you did something wrong. So C1, what is meant by group in the modern periodic table of elements? So what does it mean by group? Apakah maksud kumpulan? Kumpulan is the same vertical column. Okay, it's a vertical. Wait, it's a vertical column in the periodic table, whatever. Okay, it's a vertical column. So number 2, what is the similarity between elements T and U, which is in the same group? So they have the same chemical properties. Okay, ciri yang sama. So I can tell you T and U, right? They are in the same group, right? So they are group 18. Like I said, group 18, they are very stable. This is why we use helium to put in your balloon, because helium won't explode. We used to use hydrogen. But bad idea. Yes, hydrogen is the lightest gas. That's very good. But hydrogen is also very explosive. Would you use hydrogen in your balloon? Unless you want the balloon to explode and burn you in the face, then yes, you can use hydrogen. Do you know what is hydrogen for? Hydrogen is a rocket fuel. You put it in rocket, you see fire. So would you put hydrogen in your balloon? If you want a fire show, then yeah, why not? Okay, this is why we use helium. Helium has no reaction. No matter how you burn it, helium is just gonna chill. Yeah, doesn't concern me. Then you burn. That's not my problem. Okay, so D, element W is placed in the group between group should be 3 to 12. Okay, change this here. There's a typo here. Name element W. Now, what is element W? This is what we call a transition element. Okay, unsur peralihan. Number 2 is the same thing. What's the name given to the element? Okay, fine, whatever. So, what about this transition element? You might say, sir, I want to know something about this. What makes us don't study this? Okay, here's the thing. If you really want to know, why don't we study this? Because these elements, they are freaking weird. Freaking weird. Why do I say so? They suka hati like to be different charge one. Okay, for example, magnesium. Okay, magnesium arrangement is 2.8.2. That means magnesium really like to throw away 2 electrons to become magnesium 2 plus. When I throw away 2 electrons, I throw away 2 negative, I become 2 positive, right? So it's for sure magnesium will either be Mg or Mg2 plus. That's the thing. But here, this transition element, they are freaking weird. Like iron. Iron is Fe. Fe, suka hati, they will be Fe2 plus. But sometimes they will be Fe3 plus. For no reason. And here's the thing. Iron is silver, silvery color, right? You know iron color lah. Warna besi is like that besi color. Iron is what color? Iron is like silvery gray color lor. Iron 2 is green. Iron 3 is brown. Hey, your rust is this lah. Your karat is iron 3. That's why it's brown. You see, suka hati different color one. Hey, this is just iron, you know. Some like vanadium, this guy has 5 oxidation number. The guy can be +1, +2, +3, +4, +5. And all of them, they are different color. Suka hati, they'll be green. Suka hati, they'll be pink. Suka hati, they'll be orange. Huh? Then how to predict? That's why we don't study. Okay, after me 15 years of studying chemistry, I only study like a few elements because this thing is freaking weird. Okay, you cannot predict when they will be what charge and what color. Don't ask me. You are interested, you go Wikipedia and read yourself. I'm not going to tell you this. Okay, because it's wasting time. Anyway, question 7. Diagram below shows an incomplete mod. This is modern, not modem. I think it's a typo here. Modern periodic table of elements. So PQRST, as you can see, the questions, they are more or less the same. So draw the electron arrangement for P and T. So P, you may say, sir, how do I know this is how many proton? Okay, very easy. This is group 1, right? This is period 3, right? So just now, we use the arrangement. Okay, just now, we use the arrangement like here to determine the group and the period. Now is the reverse lah. Oh, C and D haven't. Oh, sorry. Where is it? Oh, this one. Okay. Sorry, I'm writing very fast. So that's why I go through very fast. Okay, anyway. So now we do the reverse. We know the group, we know the period. We want to find out how many electrons. So this is period 3, group 1, right? That means P is 2.8.1. Group 1, period 3. Okay, then how about T? T is group 18, period 3. So easy lah. 2.8.8. Group 18, period 3. Okay, can simple. So now they don't want this. They want you to draw. So draw lah. So this is P. Okay lah, my drawing sucks lah. You draw it nicer yourself lah. I couldn't care. Less. So this is a P. In exam, if you want to use a coin to make this thing nicer, yeah, sure, why not? I don't care. Okay, even in exam, also know this way one. Okay, I don't care about cleanliness. If you have OCD, you want to draw it nicer, then that's up to you. No extra marks for that. Okay, so it sucks. It looks like a kindergarten drawing. Fine, I don't care. So draw the ion of R. Okay, so when you see R, oh sir, I know this. Okay, I can do this. Okay, this is group 16, right? This is period 2, right? Second row, so I know this is 2.6. Yay! So I know this is 2.6. R, yay! 2.6. So is this the answer? No. You're wrong. Why? Because they want ion. They don't want atom. This one was element. Now they don't want element. They want ion. Many students will get mistakes like that. So make sure you read the question properly. So we know that R is 2.6. But is R truly happy? No, R is not happy. Because why? R needs 2 more. R needs 2 more. So how do they get 2 more? R will go and take another 2 electrons. They will rampas electron from other people, from other elements. So R will become 2.8, and this time R is R2 minus. Take 2 negative, so become 2 minus. So now when R is 2 negative, 2.8, now R is happy. R is happy. So they want the ion of R, which is this thing, not this. So your R should be, okay, you know what? I'm just going to use back the old one. Okay, it should be 2 more. And to tell this is a negative ion, you should put a square bracket and say 2 negative. Remember, it must be a square bracket. I know this is a stupid trivial thing, but if you put round bracket, your answer is wrong. Okay, don't ask me why, ask the chemist. They somehow say that it must be a square bracket because I have students who lost marks like this. Oh, the teacher say you're doing it round bracket, so it's wrong. Yeah, it happens. So make sure you do it in square bracket. Okay, and make sure you write the charge. This is 2 negative. 2 negative. That means they gain 2 electrons. Okay, next one, C. Based on the diagram above, which elements is or are metal? So which one is the metal? Okay, let me shade the semi-metal first. Semi-metal is here. Okay, so remember 1, 2, 2, 2. This row is semi-metal. Okay, anything to the left side is metal, which is P. Anything to the right side is non-metal, which is QRT. So metal is P, non-metal is QRT. Okay, easy peasy, huh? That's why I say this chapter is like a must score. Okay, here's the thing. This chapter 8 is for sure coming out an exam, and it will be a lot of questions based on this chapter 8. And the good thing is, this chapter is really easy to score because the answers are very short. It's all about drawing. It's not like your variation chapter. Remember that chapter? Wow, you have to explain why is this kid got Down syndrome? Oh, because at the 21st pair, it has 3 chromosomes. Why is the mother a carrier? Because the mother receives 1 dominant gene from the father and 1 recessive gene from the mother. No, you don't need all this long-winded explanation. It's very straightforward. That's why this is a must-score chapter. So next, 8. Figure below shows a symbol of PQR found in the modern periodic table element. So, like I said, the smaller number is usually the proton number. Okay, it might sound weird to you. Sir, why sometimes the number is at the bottom, why sometimes at the top? Don't ask me. You look at periodic table from the internet, someone, they suka hati, they will put the proton at the top. Some, they suka hati, they put at the bottom. Don't ask me why. This is more of a personal preference. If you like this number, bigger number at the top, you put bigger number up there. But the smaller number is always the proton number. So what is the proton number R? Well, that will be 19. Okay, the down here one is the nucleon. So to get the neutron number, you need to take nucleon minus proton. You minus away the positive one, then you are left with the no charge one, which is the neutron. All right, so which element is an alkali metal? Okay, you might say, what is this? What is alkali metal? Alkali metal is another name for group 1. Okay, it's another name for group 1. There's a name for it. For example, group 17, we call it halogen. For group 18, this one you know lah. Group 18 is called inert gas nadir. So group 1 is called alkali metal. Logam beralkali. So which one is it? So this is 2.6. Now you write out the arrangement first. This is 2.8.1. This is 2.8.8.1. So in fact, both of these are group 1. Okay, so that's your Q and R. So you have 2 answers here. Okay, both Q and R, they are alkali. So C, write the electron arrangement for atom P. We just did that, okay, so 2.6. Now we know that 6 is not happy. Okay, these two even crazier lah. Okay, what makes group 17 and group 1 so crazy? Do you know group 1 is really crazy metals? Okay, here's the thing. Group 1 metals, they are stupid reactive. Stupid reactive. You put fire, they burn. You put water, they explode. You put acid, they explode. You do whatever shit, they also explode. Now, why? Because you see, group 1, they all have 1 electrons outside. Okay, you imagine this. You are 1 step away from perfection. 1 step away. That means, for example, you're a guy, you are very good looking, you are very muscular, you are perfect everything, you are rich, you are everything, but you are very short. You have 1 imperfection. What will you do? You will go and fix that imperfection, right? Right? You will do whatever you can to fix this imperfection. So same here. Group 1 elements, they are freaking crazy. They will throw this one away because they are 1 step away from perfection. They will throw this thing away. That's why group 1, crazy elements. Same thing goes to 17. If you are 2.8.7, you see, same thing. You're 1 step away from perfection. You just need to get another one. You are perfect. So group 17, also crazy one. That's why your chlorine is 17. You know chlorine, right? Chlorine is a very dangerous gas. You smell chlorine, you will die. They use this in World War I. Okay, and then group 1 is like your sodium. Now, sodium, you throw in water, this thing will explode. But somehow, Sodium and chlorine, when they get married, you become sodium chloride, which is your salt. Salt is harmless. You see, because why? Because they're very happy now. Sodium is so unhappy, they want to throw one away. Chlorine is so unhappy because he wants to get another one. So, but they put chlorine in water. Hey, you know how much chlorine is in your water? One big swimming pool, they will just put a very small cup of chlorine. Your bleach, do you know you can die by drinking bleach? Your bleach is only 10% chlorine. It's enough to kill you. That 10% is enough to kill you. It's enough to make your hand feel miserable. Have you touched bleach before? If you wash your clothes using bleach the whole day, you will feel your skin is like being corroded and dried. That's only 10%. Imagine in World War I, they used 100% chlorine gas to flush you out from tunnels. Okay, that's how dangerous it is. But somehow when they react together, they kind of cancel each other out. This crazy guy meets this crazy girl, they kind of become a normal couple. Okay, that's a very shitty analogy lah. But here goes. You're a freaking crazy guy and you meet another freaking crazy girl. Somehow you guys just become okay. Okay, will you melt or something? No. If I use chlorine to kill you, your lungs will fill with water. You will drown in air. That's how it feels like. Okay, it's like you are in air, but it feels like you are in water. You're drowning in water because your lungs will be filled with water. Because all this mucus, this water in your lung, they are trying to flush the chlorine out. So you will drown. You will die a very nasty death. This is how they do it in World War I. Because you know why? In World War I, it's known as the trench warfare. You know what? Like I'm Germany, you are France. We will dig tunnels, we will dig trenches like longkang. We will hide in the longkang for like 3 weeks. You don't attack me, I don't attack you. So the Germans are sick of it. Like, this is a stupid warfare. So what they do is they ask their scientists to invent something called mustard gas, which is chlorine. So they will put chlorine to their enemy's camp to flush them out from the trenches, from the longkang, so that they can shoot them all. Freaking brutal, isn't it? That's what happened in World War I. Okay, so we don't use chlorine gas anymore, unless you're trying to kill someone. I hope not. Okay, anyway, so how does atom Q achieve stable electron arrangement? So what is Q? Q is this. So how do you achieve stable? How do you make this? How do you make yourself perfect? You will donate 1 electron. Okay, menderma 1 electron. Somehow to throw electron, we call it donate. That's the chemistry word. So explain your answer. Why donate 1 electron? This is to achieve. If I'm 8, what do I call? Octet. To achieve octet. Okay, untuk mencapai octet. Okay, to be stable. So atom mass has 4 proton, 5 neutron. What is it? 4 proton again? Okay, this is a redundant statement. Draw the structure of atom S. So, S is not here. So 4 proton, 5 neutron. They want you to draw S. Basically, you don't care about this thing because you are not drawing the neutron. So 4 proton, that means 2.2. That means S is like this. Okay, 2, 2. They want atom, right? There's no ion here, right? So we don't care about ion. So 2 electrons at the outside. Okay, easy peasy, easy peasy, So this chapter really is nothing difficult. It's all repetitive question. Okay, so next, number 9. So diagram below shows structure of S. Hello, SPM. Okay, so S, P, and M. So this one, I'm just gonna write this out. This is 2 neutron, 2 proton. Because the gray one is neutron, the white one is proton. This one is 2 proton, 1 neutron. This is 1 proton, 1 neutron. So you see, this is 2 proton, right? 2 electron. So this is neutral. This atom should be neutral. This one, 2 proton, 1 electron. So this guy should be positive. This one, 1 proton, 2 electron. This guy should be a negative. Okay, so these two should be ion. They should not be atom. So name 2 subatomic particles in the nucleus. That would be your proton neutron. Okay, take note, subatomic means inside. If they are asking for the 3 particles, then that's your atom, molecule, and ion. Do not confuse. If they are asking for subatomic, then that's proton, neutron, and electron. Subatomic means inside the atom. Particle means the whole thing. Different. The whole thing, you have atom, molecule, and ion. Inside, you have proton, neutron, electron. Very different. Don't confuse. Many students will confuse. I have seen many students in exam, they ask for subatomic or they give atom, molecule, and ion. Very different. It might confuse you. So you see, water, H2O, is a particle. It's a molecule. But inside this H, you might have proton, neutron, and electron here. So this is the subatomic. Okay, think of it this way. This is your domestic news. Berita dalam negara. This is your international news. Okay, berita antarabangsa, very different. This is out of the country. This is within the country. So very different. Okay, so which atom is positively charged? Okay, yeah, see, I can foretell what they are trying to ask already. So that will be P. Negatively charged will be M. Neutral will be S. So define nuclear number. Nuclear number is from proton number plus neutron number lah. But in the exam, you cannot write like this. You have to write in full sentence. Nuclear number is the sum of proton number and neutron number. Nombor nukleon adalah jumlah nombor proton dan nombor neutron. Very annoyingly, you have to write the whole sentence. Not here. This is for your own reference one. I'm just going to keep it short. So state the nuclear number for S, P, and M. So nuclear number is the total. So this one is 4. This one is 3. This one is 2. So 4, 3. Wow, so simple. 2 marks, 3 marks, 1 mark, 3 marks. That's like what, 9 marks here. By barely writing anything, you're just writing alphabets, you get 9 marks already. But I don't think exam is going to be this easy, but almost like this. Anyway, let's look at the next one. Okay, we have like what, 5 more minutes. So diagram below shows 2 electronic arrangement of helium and neon. You see this is duplet already. This is octet. Okay, full at the first shell, full at the second shell. So both of these, they're very happy atoms. So both atoms are stable. I explain this statement. Helium has 2 valence electrons and said to reach a stable duplet. In BM is also called duplet, electron duplet. Okay, duplet electron. Neon has 8 valence electrons and said to reach a stable octet electron arrangement. These 2 atoms do not need to donate or receive. Tidak perlu menerima atau menerima electron to achieve stable electron arrangement. See, I say very easy one, not lying to you. So B, atoms need to lose or gain electron to achieve stable electron arrangement. What happened to the atoms that they become? When you become positive or negative, you're an ion. So they become ion. Menjadi ion. So C, match the following ion with the correct description. Positive ion is when they lose electron. You throw away negative, so you become positive. Negative is when you take negative, you become negative, so you gain electron. Okay, so I got Gongxi share one. This is not a concern. This one is in chemistry one. Okay, so D, using suitable examples, state the formation of positive and negative ion from the atoms of the element. So let's use example. So the best example I can think of is sodium chloride. The salt I said just now. Sodium is positive, chlorine is negative. So 4 marks. So the first one, so we can say sodium donates 1 electron. Sodium atom, sorry. Okay, sodium atom donates 1 electron to form positive sodium ion. Okay, so natrium, sorry, atom natrium menerima 1 elektron untuk membentuk ion natrium positif. Okay, so that's your 2 marks. What's the other 2 marks? Chlorine law. So it's the reverse. Chlorine atom receives 1 electron. Okay, atom chlorine menerima 1 elektron to form negative chloride ion untuk membentuk ion, I think it's called chlorida, ion chlorida negative. Wow, so easy, it is 4 marks. Okay, basically they want positive and negative ion. So sodium is positive, metal is always positive, non-metal is always negative. I think you learned this in Form 3, right? Okay, I think you learned this list in Form 3, the kalau, nak kawin, mesti ada, zakar, fantastic, upaya, perkahwinan, Jun, dan aman. So all these are metals. Remember the calcium carbonate chapter where you burn stuff on? Do you remember? Magnesium burns at a very bright flame. Aluminium is like smaller flame. Iron is like no flame, it's just glowing. Lead is like no reaction at all, or just slight glow. All these are metals. They are all positive. So negative one is all non-metal. Okay, so I believe that's it. This one you can go home and do it yourself. Next week we shall continue with this. Okay, because next week I think there's another revision for this chapter. Next week I'll go into this isotope thing. Okay, I'll finish this by next week. Okay, so I think I'm gonna stop here. So that's it for today. Thanks for coming. Okay, happy Saturday to you all. I will see you next week. All right, so have a happy weekend. See you next week. Bye-bye.